Since its launch on December 25, 2021, aboard an Ariane 5 rocket, James Webb has exceeded all expectations. Despite initial doubts, this ambitious scientific project has become a game-changer in the field of space exploration. By harnessing the power of advanced technology, the premier observatory has opened up a new window into the depths of the universe. Its infrared eyes allow us to peer through the cosmic dust and gas that obscure visible light, providing researchers with unprecedented views of distant galaxies, nebulae, and even exoplanets. The clarity and detail of Webb's images have stunned both scientists and the general public alike. From inexplicably bright galaxies to life on alien planets and even the potential demise of our standard model of the universe, join us as we explore James Webb's most terrifying images ever seen in history. We now live in a universe full of bright objects. On a clear night, one can see thousands of stars with the naked eye. However, these stars occupy merely a small nearby part of the Milky Way galaxy. Telescopes reveal a much vaster realm that shines with the light from billions of galaxies. According to our current understanding of cosmology, the universe was featureless and dark for a long stretch of its early history. The first stars did not appear until perhaps 100 million years after the Big Bang, and nearly a billion years passed before galaxies proliferated across the cosmos. Astronomers have long wondered how this dramatic transition from darkness to light came about. After decades of study, researchers have recently made great strides toward answering this question. Using sophisticated computer simulation techniques, cosmologists have devised models that show how the density fluctuations left over from the Big Bang could have evolved into the first stars. Iterations of distant quasars have allowed scientists to probe back in time and catch a glimpse of the final days of the cosmic dark ages. The current models indicate that the first stars were likely quite massive and luminous, fundamentally changing the universe's dynamics and subsequent evolution. These stars altered the cosmos by heating and ionizing the surrounding gases. The earliest stars also produced and dispersed the first heavy elements, paving the way for the eventual formation of solar systems like our own. The collapse of some of the first stars may have seeded the growth of supermassive black holes that formed in the hearts of galaxies, becoming the spectacular power sources of quasars. In short, the earliest stars made possible the emergence of the universe we see today, from galaxies and quasars to planets and people. However, not all cosmic history is visible to us. The cosmic dark ages make up the bulk of the book's missing pages. Imagine reading Shakespeare's Hamlet and skipping some initial scenes. This is the situation that astronomers face. We have an excellent description of how it all started with the Big Bang theory, but a shadow fell across the universe as matter cooled from its early incandescence. The rift in cosmic history, the darkness where astronomers wonder what happened, is the source of mystery. A few 100 million years after the Big Bang, enormous clouds of gas collapsed, and stars, perhaps hundreds of times heavier than our Sun, sparked a light, beginning a photonic deluge that over eons illuminated the universe. The first stars were mostly made of hydrogen and helium, the lightest elements, as heavier elements did not yet exist. As these stars shined, they transmuted light elements into heavier ones like carbon, nitrogen, and oxygen, crucial to the universe we know today. The ashes from these early stars eventually formed everything we observe around us. To appreciate this milestone in our cosmic history, we must fill in the missing pages surrounding it. How did the first stars, black holes, and galaxies form? How big were they? How fast did they grow, and how was their evolution interconnected? The cosmic transition from simplicity to complexity led to a world where curious creatures gaze up at the sky in wonder. James Webb, the powerful space telescope, aids us in this cosmic endeavor. Soon after coming online, it discovered 6 enormous universe-breaker galaxies, dating back to just 500 million years after the Big Bang. This finding challenged the current view of galaxy evolution and the understanding of the universe. James Webb also addressed the Hubble tension, revealing that the universe is expanding at different rates, depending on where cosmologists look. The telescope's discoveries include glimpses of a rare type of star called dark stars, potentially fueled by the self-annihilation of dark matter. It spotted the oldest black hole ever observed, challenges assumptions about galaxy formation, and found Milky Way lookalikes much earlier in the universe's history than expected. The telescope revealed 42 pairs of Jupiter-mass binary objects drifting through space, raising questions about a new formation mechanism for planets. It captured the ancient galaxy Aztec 71, shedding light on the early universe. James Webb also discovered the smallest observed free-floating brown dwarf, prompting scientists to explore one of astronomy's most fundamental questions about the smallest stars. Astronomers used James Webb to study the cosmic web, observing the earliest strand of this structure made of 10 closely packed galaxies. It discovered the most distant gravitationally lensed object, an Einstein ring 21 billion light-years away, aiding in understanding dark matter. The telescope measured the atmospheres of distant exoplanets, identifying potential signs of life on K2-18b, a Goldilocks water world. James Webb also provided a preview of our solar system's demise, showcasing the Ring Nebula, a dying star's remnants. Its detailed images of NGC 568, a star-forming spiral galaxy, furthered our understanding of star formation and evolution. Despite its primary goal of producing scientific data, James Webb's stunning portraits, like that of NGC 568, captivated public interest. The telescope's spectroscopic instruments provided detailed spectra, confirming distances, discovering supermassive black holes, and identifying exoplanet atmospheres. Webb's observations resulted in hundreds of scientific papers, answering long-standing questions and raising new ones. The breadth of Webb science is evident in its observations of our solar system and the farthest galaxies. James Webb's science mission is just beginning, and its longevity may exceed expectations. Although the telescope will degrade over time due to cosmic factors, the wealth of data it provides will contribute to our understanding of the cosmos. The search for unknowns and remarkable discoveries continues, echoing Edwin Hubble's sentiment that with increasing distance, our knowledge fades, and the search will continue into the dreamy realms of speculation. James Webb's journey promises to be intriguing, uncovering the secrets of the universe and pushing the boundaries of human knowledge.